So what I want to do now is start talking about a more visual kind of tool, a visual way of representing the relationship between two or more sets. And these have a name. They're called Venn diagrams, V-E-N-N, right, named after a mathematician. And the way we do this, we're going to start off talking about two sets, right? What I've done here is I've made this Venn diagram, and the way we do this is we use circles to represent each of the sets. Right? So since I'm talking about two sets, I have two circles, and I'll label them A and B. You notice how they overlap, right? Because these two sets, they maybe have some content, some elements in common, and that's how I'm going to represent this visually. Everything that the two sets have in common will go in this middle region, and everything that they don't will go in these two outer regions. All right, so let's see how this works. All right, I've got an example here. I've got these two sets, and I want to represent these sets in the Venn diagram. And the way I'm going to do this, I'm going to start with anytime you're doing this, you always start at the inside and work your way out. So I'm going to do this overlap first. What do the two sets have in common? Right? I see they both have a 2 and they both have a 4. So I'm going to put a 2 and a 4 in that common region. Now I'm going to go back to my sets and I'm going to cross them out. Well, I don't want to put them on the diagram twice. So once they're on there, I don't have to worry about them anymore. So now look at A. The numbers 1, 3, and 5 are in A, but not in B. So that's how I'm going to do this. I'm going to put them in the A circle, but not in the B circle. And now I'll do it again with the B. I'm going to put the 6 and the 8 that are in B, but not A, in B's kind of outside by itself area. All right, so this is kind of how these diagrams work, right? This is how we can use them to represent the relationship between two sets. So let's see how we can do these here. All right, I want to show these different relationships. So I'm going to label my sets again, A and B, and I want to say where is the intersection? Right? Where is this part here? Remember, this is everything that the two sets have in common. So this section here is the intersection of A and B. All right, so how about A minus B? Right, well, A minus B is everything that is in A, but not in B. So look at the A circle, right? That's right here. And I want everything that is in the A circle, but not the B one. All right, so I don't want this bit here. Right, so this A minus B, that is just this part. Right, that's A minus B. All right, so how about the B complement? Now I got to clean up here a little. Right, let me clean these things out. B complement, that is everything outside of B. So I've got my B circle here, right? And I want all the space in the diagram that is not in that circle. So that's going to be here. Now I have to be careful, right? Here's where I have to stop and don't include what's inside B. Right? That's what B complement looks like visually. All right, how about this thing? You see what I've done here? I've labeled all of the regions in the diagram, right? Region 1, 2, 3, 4, and so on. And I want to kind of work this through a little. Obviously, this is a little bigger, right? Now we've got 3 sets instead of 1, instead of 2. But we're going to do the same kind of thing. So I actually see if you can maybe pause and work through a few of these. See what you come up with, then we'll do them together. Okay, so I need the intersection of A and B. Where do A and B overlap? Well, that is this section here, which is made up of 2 regions. This is region 3 and region 6. All right, well, how about the union of A and B? That is everything in A or B. All right, so that is region 2, 3, 4, 5, 6, and not 2 again, 7. Right, so that was kind of a big one. All right, how about B minus C? Look at the B circle. That's this one. And take away everything in the C circle. Well, that's this bit here. When I take that away, all that's left is region 3 and region 4. All right, and the next one, almost there. B complement, everything not in B. So I don't want these, right? What's left? I've got region 1. Don't lose track of region 1 up here. It's easy to lose. It's easy to forget about. Region 2, region 5, and region 8. Okay, one more here. Where is B? Oh, this one's a little messy. B minus the intersection of A and C. So first, where's the intersection of A and C? Right, the intersection of A and C is here. And I'm looking at B, but take away anything that was in those two parts. So take away this. What's left? What's left is region 3, region 4, and region 7. Okay, now, sometimes you'll be given a slightly modified version of this, right? What I've done here is, I know there are numbers in it, but notice over here how we're talking about these n's over and over again. Remember that n means the cardinality. It means the size of the set. Okay, so the numbers here, the number 12, for example, is not in set A. This is telling me that the size of this bit here is 12. There are 12 numbers there are 12 numbers that are in A and none of the other sets. All right, so what I'm being asked for here is the sizes of these things. For example, where is the union of A and C? Well, that's everything in A and everything in C. So I want the cardinality of this set. All I have to do is add up the pieces. 12 plus 8 plus 4 plus 2 plus 14 plus 7. That's 20. 20 is 40 plus 7 is 47. Okay, so how about the next one? The cardinality of the intersection of A and B. Well, the intersection of A and B is right here. So the cardinality will be, again, the sum of the parts. 8 plus 4 is 12. All right, how about the next one? Let's see. The union of C and B is everything in these two circles. And I want A minus that stuff. So this is the stuff that I don't want. So let me color that in. I don't want all of this stuff. All that's left is this piece. Right? It's just 12. Okay, last one. The complement of B. So here is B, and B is the stuff that I don't want. I want everything that is not in B. So let me just cross all of this out. And what's left? Well, what's left is, don't forget this 7 up here. 7 plus 12 plus 2 plus 7. That's 19. And 9 is 28. So the key thing you need to be looking for here when you're answering these kinds of questions, what are you being asked for? Are you being asked for the elements, the things that are actually in the different regions, or are you being asked for the size of the different regions?